This video is pretty brief because I think most of you understand these ideas. If we have a right triangle, in this case, you can see this marking is indicating that this is indeed a right triangle. And it's always the case that if you take a leg and you square that value and you add to that the other leg squared, you always get the hypotenuse, the length of the hypotenuse squared. So if I'm asked to find x here, x is clearly along the hypotenuse because it's the longest of the three sides here and it's across from the right angle. It would be the case that 7 squared plus 13 squared would equal x squared. 7 squared is 49, 13 squared is 169, and that's x squared. And I don't know what the sum of those is. I'm going to take 49 plus 169, and I get 218. Okay, is 13 squared what I think it is? Yeah. So I get that x squared is 218. I flip these. So therefore x is equal to, the principal root of that is 218. So the length of x is the square root of 218. Now, 218 is not a perfect square, but it can be simplified using simplest radical form. So if I take the 218, I'm going to write it in its prime factored form. Well, and actually 218 is just 109 times 2. So I can only divide it by 2. So there's not any pairs of factors in here for this square root. So I'm going to leave my answer as the square root of 218. For this next example, I'm given the hypotenuse. I'm asked to find one of the legs. So again, I take the same pattern here, a leg squared plus the other leg squared is equal to the hypotenuse squared. When I take the square root of 65 and I square that, I get 65. 14 squared, I should have that memorized. There, 14 squared is 196. So what I'm looking at here is x squared is equal to 196 minus 65. So therefore x squared is 131, and therefore x is equal to the square root of 131. This, I'm pretty sure that's a prime number, and I can't think of anything divisibility test to break that down. So I'm going to write my x is the square root of 131. This final problem asks whether or not this particular triangle is a right triangle. Basically, if the three sides of a triangle fit the Pythagorean pattern, if the two shorter sides squared and added together equals the longer side squared, then it is a right triangle. This is called the converse of the Pythagorean theorem. If it is the case that 5 squared plus 13 squared is the same as the square root of 194 squared, if this is true, then this would have to be a right triangle. So I've got here 25 plus 169, and is that the same as 194? 4, 6, and yes it is. So because these are equal, I can attest that this is a right triangle. And that's it.